Hi everyone, today we are going to continue the last class, that is EAMCET 2019 previous papers. In last class we have discussed up to problem number 10. Now we are starting with 11, that is in actual question paper it is question number 91. A solid sphere of mass 5 kgs, it is said that there is a solid sphere of mass is equals to 5 kgs rolls on a plane surface. It means that this is rolling on a plane surface like this. Now we have to find the kinetic energy at an instant when the center moves with speed 4 meters per second. If the center of this sphere, that is this point, is moving with speed of 4 meters per second, we have to find the kinetic energy. We know that the kinetic energy of the body is represented by this equation, that is total kinetic energy is equals to half mv square plus half into 2 upon 5 m r square v by r whole square. If you take common half mv square in these two equations, that is half mv square is here and half is here, m and v square here, so it will become half mv square into 1 plus 2 upon 5, because this r square and this r and this square gets cancels. The remaining is half 7 upon 5 mv square, that is here it remains 1 upon 2 into 1 plus 2 upon 5. It means that if you take this 5 this side, it will become 7 by 5. So 7 by 5 mv square, and half is we have taken already common. This total mv square and half was common, and this term we are getting from this one. So if you substitute the values, 7 by 5 is as it is, and this 2 is multiplied to this 5, it will become 7 upon 10 into mass is given and v also given. So after substituting all the values, we will be getting kinetic energy is equals to 56 joules. Now let us move on to next problem. In this problem it is said that if a planet of mass 6.4 into 10 power 23 kgs can be compressed into a sphere. It means that there is a planet and it is compressed and assumed as sphere like this and into a sphere such that the escape velocity from its surface is given, that is 8 into 10 power 4 meters per second. Then what should be the radius of the sphere? You have to find the radius of this sphere. This is diameter and half of this will be radius. Okay, it is given that mass of this one is 6.4 into 10 power 23 and the g for this planet is also given here. We know that the escape velocity of a planet is given by v is equals to 2g m upon r under root, that is if you take this root to this side, it will become v square is equals to 2g m upon r. But we have to find the radius, so I am taking radius here and making other terms to other side. It will become 2gm upon v square. If you substitute the values, we know all the values, so we are going to substitute all the values. R is equals to 2 times of gm upon v square. We know 2 and g is given here and m also given, that is this one, and upon v square is equals to here this one 8 into 10 power 4. We have to just square it because v square is given, so 8 square will be 64 into 10 power 8. If you solve this one, the radius of the planet will be 132 kilometers. Now let us move on to next question. In this question it is said that a horizontal aluminum rod of 4 centimeters, it means that there is a rod of diameter, this is 4 centimeter, and it is also said that projected from the wall. It means that this distance is equals to 6 meters. Here given an object of mass 400 pi kgs is suspended from the end of the rod, means that this end there is a mass of 400 pi kg mass, and the shear modulus of the aluminum is given as, it means that G is given, that is 3 into 10 power 10 newtons per meter square. We have to find the vertical deflection at the end of this rod. It means that due to this force it is deflected, and let it be x. We have to find this x value. G is also given. We know that the modulus of rigidity of a horizontal rod with the hanging mass is represented by G is equals to FL upon AX. We know that it is equals to mass into G into L, that is mass is this one, that is 400 pi G, and G is given. L we know that that is 6 meters, and A we know that, remember that we have to consider this cross sectional area. Okay, if you substitute all the values you will be getting G is given, the load applied is 400 pi into G is 10 from here, and L is equals to 6 meters. We have substituted here. Coming to denominator, A is pi r square, that is pi, and diameter is given 4. We are substituting here in radius. It means that 4 upon 2 is equals to 2, and x. So we have to calculate this x. So I am taking this x to the side and keeping all the values as same. Now if you solve this one, you will be getting 0.02 mm. That means that the deflection of this rod is 0.02 mm. Hope it is clear. Now let us move on to next problem. In this problem it is said that a water tank kept on a ground has a orifice of 2 mm. It means that there is a tank and there is a orifice. Orifice is nothing but a sudden opening in any tank. 2 mm diameter on this vertical side. Okay. Now what is the minimum height of water above the orifice for which the output flow of water is found to be turbulent? So it means that we have to calculate the height of the water above the orifice for which the flow will be turbulent. To know either flow is turbulent or laminar, we have to calculate the Reynolds number. Reynolds number is equals to rho Vd by nu. So it will be, in the question it is said that the flow is turbulent, so Reynolds number should be more than 2000. So it is 3000. I am keeping Reynolds number here and taking all the values, and I am finding out V. So V is equals to 1.5. Now we have to find the velocity head, which is h is equals to V square upon 2g. So we know the value of V. If I substitute this one, 1.5 square upon 2 times of g, so your answer will be 0.1125 meters, which is equals to 11.25 centimeter. Thank you for watching the video. Please share with your friends. I request you again that please forward this link into your WhatsApp group so that your friends also be benefited with this one, because we have only 15 to 20 days, so we have to practice a lot. Thank you for watching the video.